On behalf of Rohini College of Engineering and Technology, myself Y.JUSTIN Leo, Assistant Professor, Department of Mechanical Engineering, welcome you all for this Unconventional Machining Process course. The course code is ME8073 and it is a professional elective 2 for the mechanical engineering student for the regulation 2017. So here in this video session, we'll be studying about Unit 1, that is Introduction and Mechanical Energy-Based Processes. And we'll be studying about Introduction to Unconventional Machining Process. So Introduction to Unconventional Machining Process is an animated view. And coming to the syllabus, in Unit 1, Introduction and Mechanical Energy-Based Process, you have all these topics. So what would be the objective on studying this Unconventional Machining Process course? So the students will be able to learn about various unconventional machining process, the various process parameters and the influence on performance and their applications. And in the syllabus for the first unit, the students will be studying about the unconventional machining process, the need to have this machining process, and the classifications, merits, demerits, and applications, and abrasive jet machining, water jet machining, abrasive water jet machining, and ultrasonic machining, and working principles, and the equipments used, the process parameters, and industrial applications, and various advantages and disadvantages of the unconventional machining process. So in Unit 2, there is thermal and electrical energy-based processes. So we'll be studying about electric discharge machining, wire cut electric discharge machining, working principles, equipments, process parameters, surface finish and MRR electrode, and the tool power and control circuits, the tool wear, dielectric, flushing applications, then laser beam machining and drilling, and the plasma arc machining, electron beam machining, its principles and the equipments, the types, beam control techniques, and its applications. Unit 3, that is chemical and electrochemical energy-based processes. We'll be studying about the chemical machining and electrochemical machining, etchants, maskings, techniques of applying maskings, and various process parameters, surface finish and MRR applications, and the principles of ECM, equipments, the surface roughness and MRR electrical circuits, processes parameters, ECG and ECH applications. And in Unit 4, that is advanced nano finishing process, we're studying about the abrasive flow machining and chemomechanical polishing, magnetic abrasive finishing, magnetorheological finishing, magnetorheological abrasive flow finishing, and the working principles, the equipments, effects of process parameters, applications, advantages, and limitations. So in Unit 5, there is a recent trends in the non-traditional machining process. So the students will be studying about the recent developments in non-traditional machining process, their working principles, equipments, effect of process parameters, applications, advantages and limitations, and the comparison of non-traditional machining processes. So this is these are all the textbooks and references for the students for this unconventional machining process course. And what would be the course outcomes for the students? The students, upon completion of this course, they will be able to explain the need for unconventional machining process and its classification, from Unit 1, and they will be able to compare various thermal energy and electrical energy based unconventional machining process from Unit 2, and the students will be able to summarize various chemical and electrochemical energy based unconventional machining process from Unit 3, and from Unit 4 the students will be able to explain various nano abrasives based unconventional machining process, and the students will be able to distinguish various recent trends based unconventional machining process from Unit 5. So, introduction to unconventional machining process. Normally, traditional machining is mostly based on the removal of materials, like using the various tools that may be harder than the materials themselves. And new and novel materials, because of the greatly improved chemical, mechanical, and thermal properties, are sometimes impossible to machine using traditional machining process. So in that case, you have to go for this unconventional machining process. So this traditional machining methods are often ineffective in machining hard materials like ceramics and composites, or even machining under very tight tolerances as in micro machine components. So in that case, unconventional machining process is preferred. And the need to avoid surface damage that often accompanies the stresses created by conventional machining process. Example, aerospace. So what is unconventional machining? So an unconventional machining, also called as it's a non-traditional machining process. So that is defined as a material removal process in which there is no direct contact between the tool and the workpiece. So in this type of machining process, a form of energy is used in order to remove the unwanted material from a given workpiece. So conventional machining process is metal removal, nature of contact, and scrap. So conventional machining process all have all these three important process. And unconventional machining process, it is called unconventional machining process or non-traditional machining process, and the second one is unconventional forming process. So normally you have two basic types. So in machining process, metal is removed, that is, metal has to be removed, and no direct contact between tool and workpiece in unconventional machining process. And in unconventional forming process, metals are removed, releases large amount of energy in very short time interval. So these are the basic difference between the unconventional machining process and forming process. So what is the need for unconventional machining process? So machining produces finished products with high degree of accuracy. So when you conventional machining, so in conventional machining you have to use cutting tools which may be harder than the workpiece materials, and it needs a contact between the tool and the workpiece. So it needs a relative motion between the tool and the workpiece. So in that case, the alternate way you have to go for is you have to use an unconventional machining. So need for unconventional machining. So the need for higher productivity, accuracy, and surface quality, improve the capability of automation system, and decreasing the sophistication, that is decreasing the investment cost. So very hard, fragile materials difficult to clamp for traditional machining. So when the workpiece is too flexible or slender, you need to go for unconventional machining process. And when the shape of the part is too complex, you can go for unconventional machining process. Internal and external profiles or smaller diameter holes, you can go for unconventional machining process. So these are all the classification of unconventional machining process or a non-traditional machining process. So here, based on the energy type, you have mechanical, electrochemical, chemical, and thermoelectrical. And based on the basic mechanism, and here in mechanical you have erosion, and in electrochemical you have ion displacement, and for chemical the basic mechanism is ablative action, and for thermoelectrical you have vaporization and fusion. And coming to the source of immediate energy, for mechanical you have pneumatic or hydraulic pressure, and here for electrochemical you have high current, and for chemical you have chemically reactive agent, and in thermoelectrical or vaporization you have high voltage and amplified light, whereas here in fusion you have ionized material. And coming to the transfer energy medium, for pneumatic or hydraulic pressure you have two modes, that is high velocity particles and high velocity liquid. And here for electrochemical, transfer energy medium is electrolyte, and for chemical you have environment. And in thermoelectrical, for high voltage you have dielectric and vacuum transfer energy medium. And similarly for vaporization, in thermoelectrical you have radiation, and in thermoelectrical fusion you have hot gases. And the processes used here in mechanical non-traditional machining processes: USM, AJM, AFM, MAF, and for high velocity liquids you have WJM, AWJM, and for electrochemical you have ECM, ECG, ECH, and electrochemical dissolution and electrochemical erosion. And for chemical non-traditional machining process you have CHM. And for thermoelectrical, that is for vaporization, and you have this for high for dielectric you have EDM, micro EDM, CNC EDM, die sinking EDM, rotary EDM, dry EDM, and WEDM, CNC WEDM, micro WEDM. And for vacuum you have EBM. And similarly for in the thermoelectric under vaporization you have LBM, laser milling, laser micro machining. And for thermoelectric under fusion you have PAM. So these are all the classifications of non-traditional machining process which we'll be studying in further chapters: the working principles, constructions, applications, advantages and disadvantages. So these can be this unconventional machining process can be classified according to the source of energy used normally to generate such a machining action, that is mechanical, thermal, chemical and electrochemical. So when you come here for mechanical, that is erosion of work material, it happens by a high velocity stream of abrasives or fluids, or even both. And coming to the thermal energy is applied here to a very small portion of the workpiece, and causing that particular portion alone to be removed by fusion or by vaporization of the material. So which we saw in the previous calculation, by vaporization or by fusion. The thermal energy is generated by conversion of electrical energy. And coming to the chemical, that is chemical non-traditional machining process. So here most materials, normally metals particularly, are susceptible to chemical attack by certain acids or other agents. In chemical machining, chemicals selectively remove material from portions of the workpiece alone. And next is the thermochemical. Its a mechanism is the reverse of electroplating. So these are all the classifications. And coming to the selection process. So the selection process is based on following parameters. Physical parameter, shapes to be machined, process capability, economic consideration. So the unconventional machining processes, you have different various unconventional machining processes, and the process is selected based on these following parameters. And these are all the physical parameters. For ECM, you have this for ECM, EDM, EBM, LBM, PAM, USM, AJM. You have all this the potential volt, current in amps, and power in kilowatts, gap in millimeter, and the medium used and the work material. So these are all have been tabled out here. So these are all the physical parameters which differs for each and every unconventional machining process. And these are all the shapes to be machined. For example, holes, micro, small, deep, and shallow. The machines, unconventional machining machines used is LBM, EBM, ECM, USM, and EDM. And for precision work, you can use machine USM and EDM. And for honing, you can use ECM. For etching, you can use ECM and EDM machines. And for grinding, you can use AJM and EDM machines. And for deburring, you can use USM and AJM machines. And for threading, you can use EDM machines. And profile cut, you can use the PAM machines. And these are all the process capabilities or machining characteristics. And these are all the different machining process machines. And the LBM, and for that you have all this MRR and surface finish accuracy and the power requirement. So these for various processes. Now unconventional machining processes, you have all this process capabilities or machining characteristics. And this is the process economy for various machining process, and these are all the capital costs for and the tools and fixtures, and for power requirement and for efficiency. So this table shows the process economy for various unconventional machining process. So advantages of unconventional machining: the high accuracy and surface finish of the components to be machined is obtained. So no direct contact of a tool and workpiece. So there is less or sometimes no wear. The tool life is more, and it's a quicker operation. So these are all the disadvantages of unconventional machining process. The cost is high, and the complex setup, skilled operator required, and disposal of waste, byproducts of chips, work holding devices for larger cutting posts, heat generations not possible without chips. So these are all the disadvantages of unconventional machining process. So with this we come to an end with this introduction part of the unconventional machining process of Unit 1. So thank you and have a great day.